Hello students, Mr. Courtney here. In this video we're going to be looking at naming acids. So inorganic acids, and when we say inorganic we mean not containing carbon, they're always going to begin with hydrogen. Hydrogen is going to be our cation, so hydrogen is going to be positively charged. And if we have a positively charged species, then we must have some negatively charged species coming together to give us our acid. So that means our acids are ionic compounds. So it's important to know that acids are ionic compounds because we have a positively charged species and a negatively charged species. So there's going to be an electrostatic attraction between them that's going to create an ionic bond. When we name these inorganic acids, we're going to name them based on the anion present. So we're going to come across two types of acids. Those are binary acids. These are acids made up of hydrogen and one other element. And that other element is often a halogen. But we can have others like this, H2S. This is a binary acid because we only have two elements present, hydrogen and another element. And in this case, it is sulfur. Acids of oxyanions. These are made up of hydrogen and a polyatomic ion. Usually they're going to contain oxygen, so we call them oxyanions. Also, for those that do not contain oxygen, the few that do not contain oxygen, we call them ternary acids. So let's look at how we're going to go about naming these. Naming the binary acids. In naming binary acids, it's a simple four-step process. We start with the prefix hydro to represent our hydrogen present. So we start with the prefix hydro to represent our hydrogen present. Then we take the root of the anion, which is chlorine in this case. So we take off the INE. So we take off the INE, we get chlor. Then we add the suffix ic, then the word acid. So together, we put all these together and we get hydrochloric acid. Example, HBr, hydrobromic acid. We start with the prefix hydro. Then the root of the anion from bromine is brom. Then add the suffix ic, then the word acid. So to name our binary acids, here we take the root ic, suffix ic, then the word acid, and we have hydro at the front. So that tells us our binary acids are always going to begin with the prefix hydro. Our polyatomic acids will not have the prefix hydro. So that's one way you can differentiate from the name when we look at these. If it begins with the prefix hydro, then we know for sure that it's a binary acid. If it does not, then we know it's a polyatomic acid. Now, when we name in the acid between hydrogen and iodine, there's a slight difference. Because of that O, so we have hydro, io. So instead of putting that O and that I together, we drop the O on the end of hydro. As we saw here, we drop the O. So we call it hydriodic acid instead of hydroiodic acid. That's our one exception here. Now, when we name our polyatomic acids, the first thing to do is to identify the ion. And in this case, our ion is NO3, that is nitrate. And remember we said we do not have the prefix hydro when we name in acids of oxyanions or polyatomic acids. So we start with nitrate and we look at the ending ATE. We're going to drop the ATE and add the suffix ic and then the word acid. Nitric acid or nitric acid. So whenever a polyatomic ion ends in ATE, we're going to replace the ATE with the suffix ic, IC, then add the word acid, and that's how you name your polyatomic acids. Now, if the polyatomic ion ends with ite, we drop the ite and we add the suffix OUS. So in this case, we got nitrous acid because we had nitrite. We had nitrite, drop the ITE, add OUS, we get nitrous acid. Now, there are a few exceptions. Sulfur and phosphorus. Whenever an acid contains sulfur, we're always going to use sulfur as the root. So here we have sulfate, we use sulfur as the root. Here we have sulfite. We use sulfur as the root. But it ends with this one, sulfate ends with ate. So we add the suffix ic, then the word acid. So we get sulfuric acid. Sulfite ends with ite. So we add the suffix ous, then the word acid. We get sulfurous acid. Phosphate, phosphite, similar. We use phosphor as the root. And this is phosphate, so we add ic. This is phosphite, so we add ous. So we get phosphoric acid here, and we get phosphorus acid. So it's important that you know these exceptions. And this basically sums up, it's just a cool way of looking at it in a flowchart form. Now, if it contains oxygen, yes or no, no or yes. So if it does not contain oxygen, then we're going to start with hydro plus the anion root, then ic, then the word acid. No, yes, sorry, if it contains oxygen, we check the ending of the anion. If it ends in ite, replace the ite with ous, then the word acid. If it ends with ate, replace the ate with ic, then the word acid. So if we were to name the following, okay, I'm going to name a couple with you and I'm going to leave it to you to do it. You can pause the video and come back and look at the solutions. So we already did this one. Binary acids, because we only have two elements, so we start with the prefix hydro. And we have bromine, and the root for bromine is brom, ic, and then the word acid, hydrobromic acid. Now this one is a polyatomic acid because we have hydrogen and a polyatomic. So we do not name hydrogen, we'll leave it blank. We know this is carbonate. We're going to drop the ate and add ic. So that's carbonic acid. Okay, so you can go ahead and pause the video and look at these, and then come back and look at the solutions. Alright, so let's go ahead and look at the solutions to these. And there you have it. Okay, remember this one at the bottom is acetate. So we drop the ate, then we add ic, so acetic acid. Alright, let's look at naming these. We're going to write going to write the formula for these following acids. So we have hydrosulfuric acid. We have hydro. That tells us it's going to be a binary acid. And remember, all acids are going to begin with hydrogen, so they're going to have a hydrogen in it. So we know H+. And sulfuric. Now remember, we said any acid that contains sulfur is going to also have sulfur, always have sulfur as the root. So S. And since it's binary, it has to be S minus 2. It's not polyatomic. Now this has to create an electrically neutral compound. 1 positive, 2 negatives. We have to do our crisscross method. So that gives us H2S. And that's hydrosulfuric acid. Acetic acid, we start with H+. And since we don't have the prefix hydro, that tells us it's polyatomic. So you look for your polyatomic ion acetate, drop the ic, and add back ate. That's how we know it's acetate. And acetate is CH3COO minus, or you may see it written as C2H3O2 minus. So either way you will see it like that. So we add our acid. We have 1 positive, 1 negative, not add our acid. We look at the compound, 1 positive, 1 negative. So we're going to get H+. Sorry, not H+. We're going to get HCH3COO. Or if we do it like we did at the bottom here, we get HC2H3O2. So you see it this way. You may even see it written as this, putting the hydrogen last in this case. CH3COOH, or you may see it as C2H3O2H. So these are different ways that you may see it written, and I just bordered them in black so you know that these are the different ways you may see this one written. Now there's an exception, HCN. So we look it up and we see this is CN, so we know this is cyanide. But it's a polyatomic ion and it ends with IDE. And if we look back at naming all our binary acids, the anion from our binary acids, all of them ended with IDE. So that means this one is going to be an exception. We're going to name it as if it's a binary acid. So we put hydrogen, so we put hydro. So we have cyanide, drop the IDE, ic, then the word acid. So that gives us hydrocyanic acid. Okay, so let's name these, write the formula for these acids. So we look at the acids, determine if they're polyatomic or binary. So the first one, periodic acid. No hydro, so we know that it is polyatomic. So we drop the ic. Remember, what did we replace? Put ic in place of 8. So we look up periodate, and it's going to begin with hydrogen. So that's our first ion. And then iodate is IO4 minus. If you don't remember it, look it up on your polyatomic ion chart. All right, so periodate IO4 minus. Charges are equal but opposite, so that will give us HiO4 as our acid. HiO4 as the acid. Second one, hydrosilinic acid. We have hydro, so that tells us it's binary. And if we drop off the ic, then we're going to put back ide, selenide from the element selenium, HSE minus 2, so that's H2SE. Arsenous acid, and that is a polyatomic acid because we have no hydro. Take off the OUS, add back ITE. Arsenite, so that's H plus as our cation, and arsenite is ASO3 minus 3. So that means we need H3A. Why I keep writing S before the A? H3 ASO3, and that's our arsenous acid. Chromic acid, again, this is polyatomic because we do not have hydro, so we drop the ic and we add back ATE, so that's chromate. So you're going to look up chromate. So we start with hydrogen, and chromate is CrO4 minus 2, so that's going to be that. Then we need to balance our charges, make sure our positive is equal to our negative. We need 2 of the hydrogens because we're going to do the crisscross method. So that is H2CrO4 uppercase. Hydrofluoric, hydro, we know it's binary, fluoric from fluorine, H plus F minus, that gives us HF. There you have it. And that takes us to the end of naming acids. You can review this as many times as you need to. So we're done here. Until the next time, I'm out. Blessings.